Well, it's so great to see so many of you here, and thank you for joining for our retreat. I think I was able to be in and out during the day, and I've been enjoying the content tremendously. We have a wonderful panel for you coming up, and I was just going to kick off the session by spending just a very small number of moments telling a little bit about some of the work that we've done in our group over the last year or two in the area of, I guess, social good. I mean, we hope to do medical good, and if we do that at scale, perhaps we think that is social good as well. And certainly one of the themes of our work is that we can often learn a great deal by measuring a single individual very deeply, but extending that, of course, to a whole population gives us a large number of insights that we can use both at the individual level and at the population health level. So just very quickly to tell you about a study that really started, here are my disclosures. I usually make the point in the recent past that for most of the early part of my time on the faculty at Stanford, my disclosures were much like the ones on the left. Pharma companies, biopharma companies, but over the last few years, the tech companies, of course, have become very interested in healthcare. And that's one of, I think, the major advantages of our data science initiative here is that we have an integrated initiative between all the schools at Stanford, and in particular, I spend a lot of time between engineering and medicine. So this is just for these few minutes where the story began. Actually, in this room, we have a conference every year called Big Data in Biomedicine, and it's evolving towards the use of the phrase precision medicine and precision health. And a couple of folks from Apple contacted us at the end of one of those conferences. They didn't actually tell us at the time who they were, and they were very secretive, as Apple are well known for. And it was only later we really found out that they were from Apple. But that started a year of working together with several academic medical centers and Apple in building what later became ResearchKit, and what was launched in March 2015 at the Spring Forward event. And the idea was really from the very highest level of the company, the idea that this technology could be used for human good, for medical good, and particularly for clinical research. And so we were particularly focused on cardiovascular disease. I'm a cardiologist here at Stanford. And so we particularly were excited by the possibilities of using technology to access the cardiovascular system. Heart rate, for example, that many wearables that many of you are probably wearing, heart rate's a very accessible feature, and although it's very straightforward and simple, it actually tells us a great deal about the cardiovascular system, and of course more and more as we learn what's normal for you. And so when Apple launched something, the world pays attention, and that you should understand that most of these studies that we do at Stanford and other academic centers, we stick a poster on the wall around campus, and there's a little tear-off slip, and if you have the phone number, you call up, and then you go and visit someone in the clinic, and then you sign a 17-page consent form, and then finally you start and you're part of the study. And we're lucky if we get a few hundred people over the course of a year. And in the first week, 10,000 people signed up for the study. In the first month, 40,000 people signed up for the study. And so we weren't really ready for that. This was a small team of 2 or 3 people, and suddenly we had a clinical study that was as large as almost any that we had performed previously. Of course, it's a little bit easier because it's sensors like this from which the data comes, and that makes it much more convenient. And the consent for the trial comes from these devices as well. You fill out the consent on the phone, and if any of you are interested, by the way, in being part of the study, you can go to the App Store right now and download it for free. This is the sort of data we get. After a few months, we had a quick look at the data, and this was a publication from the end of last year. But of course, when you get data at scale, we can start to apply the sorts of tools that are very familiar in the technology sector, and insurance sectors, financial sector, and others, but to healthcare data. And this is not something we've done much of in healthcare. We tend to have very low throughput data. We do a cholesterol panel, and we get 5 numbers back. And if we get 10 numbers, we all get a bit panicked and freaked out in medicine. So when 40,000 people are giving you streaming data every day, then that's the sort of time that we turn to our friends in engineering for help. And these are fairly straightforward machine learning approaches. But again, I can let you know that in the 50s and 60s, before we even knew that exercise was good for you, there was a time when we didn't know that exercise was good for you, it took about a decade to produce this result that was produced in 1 week. With this study, which is to say that the more you exercise, the lower your chance of having chest pain, diabetes, heart disease, or joint pain. And more than that, with this data, of course, we get patterns, and that, I think, is one of the exciting things. We can map it to the country and see who's, in this case, who's active and who's not. The deeper, darker blue is more active, and you can see how satisfied with life you are according to your bedtime, if you want to put yourself in one of those categories. Also, you probably have a watch that tells you to stand up if you've been sitting down, like today, for too long, and you might have wondered, is that useful or not? This is some of the first data that ever really suggested that it might well be useful. So we looked at the transition status. Again, when you have a sensor, you can look at transitions rather than just asking someone how much they did. And regardless of your overall activity level, the more transitions you had between one state and the other, the less likely you were to have these heart conditions shown on the right. So transitions, just getting up and down, is probably worth it, regardless of even the overall amount of data. Genomics is a big deal, and we partnered with 23andMe, so we have several thousand people now who have 23andMe data and data in our study. So we like to combine these large data streams from wearables and from genetic studies. And we also, here's a little bit on on one of the studies we did, testing to see if the devices are really ready for prime time, ready for use in the clinic. Many of my patients bring me this kind of data to clinic, and we were very interested to know, is this data good enough for the clinic? And so we did these studies that are shown here, these particular wearables that you see, and you can see a % error, then good is blue and bad is orange. Pretty good at heart rate. Actually, surprisingly to us, these devices are now really quite good at heart rate, probably approximately clinical grade, under 5% error. But for energy expenditure, so if you're using this watch to decide that I did 300 calories worth of exercise in the morning so I can eat the donuts that are on display outside at lunchtime, I suggest you do not do that. The error rates were between 10 and 90% for calorie estimation. So you want to be a little bit careful over-interpreting those. And people always ask me which one was the best. They're actually all pretty good. Apple and Fitbit did the best in this particular study in both, but all the devices were pretty poor overall at energy. So the world seems to pay attention. This was, for 2 days we were being called relentlessly after doing the study, even though it was a very straightforward little study, but it turns out people are really quite interested in whether these devices allow you to eat the donut that you can see in the middle. So, and then is it ready for the clinic? This is the last thing I was going to share with you. This is a patient of mine who basically he was sitting in front of the TV, and his Fitbit told him he was in the fat burning zone. And he thought, no, I'm not in the fat-burning zone, and that didn't seem quite right. And he didn't feel quite right, but not enough that he wasn't going to wait till the end of the TV show he was watching. But because his Fitbit was basically saying something seems to be up, he came to the hospital, and it had actually exactly determined this dangerous heart rhythm. None of you are doctors, I don't think, but this is not a good sign when your heart rhythm looks like that. That's basically a potentially fatal rhythm of the heart that his Fitbit picked up. So I think the message is that probably it is ready for prime time. This is actually from our electronic medical record. Obviously no names shown, but we actually now through a HealthKit application can bring in step data, heart, simple stuff, blood pressure, height, steps, weight, pulse, and put that actually in your medical record. So I think these two worlds are coming together, and that's certainly what I'm excited about and what I'll be excited to share with the panel. This is actually a true story. People come and pretty much ask if they need a primary care physician anymore. Now they have Google. So with that, I just want to move on and have the panel. I will move myself over and I'm happy to take questions, but I really want to hear from our panelists. So I think we want to move ahead with that. And I guess, Emma, you're first up. So Emma's an assistant professor in computer science, and I will let her take it from here. Thank you.
Hi, and I think that's a great segue into some of the stuff I'm going to talk about today, which is human-in-the-loop reinforcement learning. Let me just start off with some of the motivation for the work that I do. Probably everybody, maybe even today, has seen a headline about whether AI is going to replace humans. And in fact, it's been a really large focus of artificial intelligence for the last 50 years, is whether or not we can create intelligent agents that are going to replicate human performance and maybe replace us. And there's some good evidence that we may be getting to machines that can do that in certain areas of our lives, like taxi drivers and perhaps being able to diagnose things like skin cancer and other areas. But to me, the real power is to see that AI can amplify human intelligence, not replace us. Who here has seen The Matrix? Okay, a number of people have. I'm always dating myself a little bit when I bring up this movie, but nevertheless. So in it, as a reminder or as an introduction for those of you who haven't seen it, there's a part where Trinity, one of the main characters, needs to fly a helicopter. And what she does is she downloads a program into her brain, and about 20 seconds later, she can fly this helicopter. And I think this vision of kind of demand-driven, insanely efficient, and presumably somewhat engaging education is really powerful, and it's something we're going to need going forward. And I think that thinking of AI as these tools to help us sort of achieve that kind of amplification of our own capabilities to advance our own goals is really powerful. So the way that I think about this is in the context of a part of machine learning, which many of you might have heard of, called reinforcement learning. But just as a quick refresher, I think one of the main goals of reinforcement learning is to move beyond some of the huge successes we've had in prediction, which we were just hearing about too in healthcare, and leveraging the data that we have and moving it to decision making. So we really want to move from both what do these sensors tell us, but then what should we do with that information? What's the utility of that information? And in the context of reinforcement learning, it works something like this. So you have a machine that could maybe take an action. So in this case, it's playing a video game, so it could do something like turn left. And then it gets to see how the world changes when it does that action. So maybe the pixels change, and maybe it also gets some sort of information like a score. And one of the big challenges here is that the agent doesn't know in advance how the world works. So it doesn't know when it turns left what that's going to do to the pixels, and it doesn't know how that's going to change the score, and yet it's trying to learn how to make good decisions. And in particular, the way that we're going to generally call those good decisions is in the form of reward. And so score is one form of reward, but there are lots of other forms of reward that I'll tell you about shortly as well. And the goal is that the agent wants to figure out how to take the information about the world, so like the history of the previous things it's tried and what's happened and what reward it's gotten, to try to figure out how it should make decisions in the future. And we're going to call that a policy, a mapping from this history of the prior things it's done to what it should do next in order to try to get good outcomes. Now, there's been a huge amount of excitement about this in a lot of different domains. I'm really excited about what I call human-in-the-loop reinforcement learning, where we're replacing the sort of like an artificial system like a robot or a video game with a person. So now we're going to have an intelligent agent that's trying to help a person achieve some goals. And yet the rest of this sort of algorithmic and mathematical framework is exactly the same. So how does this change things? Why is it different to think about having a person in the loop that we're trying to help rather than thinking of a video game or a robot? Well, there's a number of different important distinctions, and we're trying to tackle a lot of those in my group. One of the important things is as follows. If you have an agent that's trying to play a video game and it fails to play the video game horribly for the first 9 billion trials, and those numbers are slightly exaggerated, but not so much, it's okay. It doesn't really matter. It costs you a lot of computation, but it wasn't really so bad. In contrast, we don't want to not teach 9 million students fractions. That would be unfortunate. We don't want to accidentally harm 9 million patients. And these are cases where it's really costly to experiment, and we need to be careful in the data we collect. Unfortunately, it's also really hard to model people. We don't have good models of student learning. We don't have particularly good models of consumer performance. We don't have particularly good models of physiology. We certainly have some nice baselines, but it's still really hard to model people. In contrast, in a lot of robotics, we have pretty good models of physics. So we're sort of stuck in many ways because we have systems where it's really costly to experiment, and yet we don't know how to model them very well. And so that's one of the big distinctions between a lot of the work that's happened historically in reinforcement learning and the type of work when we think about humans in the loop. Now, fortunately, we have some benefits in this setting, which is we collect lots and lots of data about people and the decisions that they make and the outcomes in their lives, whether in the healthcare setting or education, et cetera. And in particular, I'm really excited about how do we use that data to do counterfactual reasoning. And as a refresher, counterfactual reasoning is what we do when we try to hypothesize what would happen in something different than what we actually tried. So in particular, in the context of electronic medical records, we can have results of, say, observational data, where we look at sequences of treatments given or interventions to patients, and then what happened in terms of the resulting outcomes or their sort of quality-adjusted life years, et cetera. And what we want to do is to be able to take this data and not just predict what might happen for a new person, but actually be able to make recommendations for that new person. And that's a really challenging problem because, of course, we haven't treated this person in the past with all these different ways we could treat them, and so we have to hypothesize what would happen. And I think one of the really big challenges here is that data is not independent of those decisions. So if I do a surgery over a person, then I can't see what it would have been like if I didn't do that surgery. So that's why it's called counterfactual reasoning. And it's a really important problem that comes up in economics and statistics and many other domains. And we've been thinking about it in the context of these reinforcement learning systems. So in particular, one of the ways it first came up for us a few years ago is we were trying to maximize engagement in an educational game. So this is a refraction. It's been played by about 500,000 students, and it's used to teach basic fractions ideas. And our goal was to figure out how do we adaptively and personally select levels for students in a way that's going to maximize engagement. We had access to prior data with some randomization of how these levels were selected. And what we did is, using some combination of some statistical techniques in reinforcement learning, we could hypothesize and evaluate in advance what new strategies for adaptively presenting these levels would do in terms of engagement. So how quickly would students drop out playing this game? And then we could verify that in a study with about 2,000 other students to show that, yes, really the policy that we found was 30% better in terms of engagement than the prior results. And the reason that I like this result is because it both shows the power of the statistical techniques for us to sort of hypothesize the future before we try it, as well as it verifies those with real students that this is really a trustworthy estimate. So that's one of the differences between thinking of sort of optimizing for video games versus optimizing for people. But another is that in a lot of these sort of typical domains with robots or with video games, the system is closed. So I can't decide halfway through playing my Atari game that what I really need is a way to teleport to a much further level. I can't sort of input that inside of the game. I can't change the game specification. But in the real world, we change the specification of the system all the time. So if the Zika virus appears, we don't say, well, that's too bad. We don't have any vaccine for the Zika virus. I guess we're just stuck. We instead invent new vaccines. And then similarly, in many cases, if we don't have tools or sensors to try to monitor the things that we care about, then we invent new sensors, just like what we were hearing about before. So these systems aren't closed, even though we normally think of them as closed systems. And these have implications for many different areas, certainly including healthcare and consumer marketing. So the way that we're thinking about this is, how do we extend reinforcement learning to consider having another form of human in the loop, which is an outside expert, which the system can actively reach out to when the system realizes that maybe it could do better if it changed its specification, if it changed the way it tried to observe the world or the actions it gets to take. And we've been investigating this in the context of education as well as different forms of crowdsourcing. And ultimately, I think our goal is to really try to create systems that do better by combining machines and people than either could do alone. And one of the ways that we envision this is by thinking about sort of systems like crowdwork systems, where we're trying to adaptively train people to do tasks that we don't know how to train well, and using machines to figure out dynamically what material is effective, as well as having people create the training materials automatically for training future people. So we sort of have this ecosystem of machines and people that should be continually evolving and getting better and better. I just want to close on a slightly philosophical note because of the title of this panel. I thought I'd go speculative for a second about where I think humans and machines are going next. I think right now, one thing that's really interesting, whether, again, if you listen to the news, is there's a lot of concern and interest in interpretable machine learning. One thing that I've been personally thinking about a lot recently is whether we need interpretable machine learning or trustworthy machine learning. And what I mean by that is that I think that, for better or worse, many people probably don't understand how their microwave works. But when we get up in the morning, we're not terrified that our microwave is going to suddenly take over our job or our house or kidnap our kids. We have basic trust in our microwave, and it's not because someone else in 10 other houses tried their microwave and it worked there. So I think that one of the things that comes up with machine learning is that we're in this data-driven paradigm, and the way we use that data to make generalizations of the future and how these systems will work is often still an art and not completely a science yet. And so I would argue that in many cases, while in some cases we need interpretable machine learning, in many other cases what we want is trustworthy machine learning. And that if we had ways to verify or ensure that the systems would act in the ways that we want, things like safe and verifiable machine learning may be what we really are wanting often when we talk about interpretable ML. The other thing I'll say is that we're seeing a lot of work on and the dangers of adversarial settings. And that happens because often the way that we're thinking about the data we collect is that we're assuming it's sort of being independently generated without any sort of interested agents participating. But of course, often there are interested agents. And I think the adversarial setting is a really important case to think about. But because I'm an optimist, I also like to think a lot about the cooperative or collaborative setting. And we've seen that there's some really nice results coming out of Wisconsin and some other places that if it's the case that we have machines and humans working together closely, the amount of data we need to train these systems and the results that we can get may be much more powerful than we can already achieve. So I think it's really exciting to think about that sort of optimistic view of how the two systems could work together. So just to close, I work on human-in-the-loop reinforcement learning, and I think it's a really exciting new way that we could be trying to use these systems to try to get to better outcomes for everybody. Thanks.
Thanks so much, Emma. That was great. So who's next? This is like very exciting. We see it. Do you guys have slides?
I don't.
You don't? Okay. Well, that's great. Shall we just go down next? Rob, you
Okay.
want to go next? Rob Reich is a professor of political science and director of the Center for Ethics in Society. Rob, welcome.
Good afternoon, everyone. Well, I am, in certain respects, the odd person out here amongst this crowd because I come to you from across campus in the political science department where I teach political philosophy and where I direct the Center for Ethics in Society. I'm not a data scientist, but I've begun working with a bunch of folks here on campus in order to explore what I'll describe as the social and ethical dimensions of the technologies we'll be talking about. I should say, by way of introduction as well, that philosophers in our calling, our vocation, we think of ourselves partly sometimes as provocateurs, partly sometimes about seeking out the centers of power where they exist and asking inconvenient questions. And I have to confess that my temptation in arriving here today is to acknowledge that the engineers and data scientists of the world are certainly farther up the totem pole of status than philosophers tend to be. And so I come to ask perhaps what you might think of as some inconvenient questions about the social and ethical dimensions of technology. Also, just something that amused me, the folks here who organized the conference sent a little single page about tips for really effective presentations. And it included the observation, no presentation that operates at the level of 30,000 feet is a good presentation. And I thought to myself, that's basically all that philosophers ever do, is we operate at 30,000 feet. Why do we do that? Because we have a broader view of the landscape. You get clarity about the big picture. You get to see where small things that you can't notice down in the weeds amount to big changes. So against advice and obviously unapologetically, I'm going to operate at 30,000 feet. Final thing, here at Stanford, it's no secret that the folks on this side of campus have played an enormously consequential role in stimulating some of the most significant and consequential innovations in technology that have had profound effects across so many dimensions of our lives. And the university is, I think, catching up to the fact that its status as a leading university in the world oughtn't rest on that extraordinary accomplishment by people in the computer science department, the School of Engineering, and School of Medicine, et cetera, but that the university ought also to be a leader in studying humanistically the social and ethical dimensions of the very technologies which are so important and consequential. So in that respect, I view what I'm about to say today as an initial effort at setting an agenda for some questions. Perhaps you can view me as the Eeyore in the room to the enthusiastic Tiggers amongst us all. I want to make basically just 3 quick points. I want to talk about some of the things which already you are aware of if you pay attention to the news that should lead you to ask questions about the social and ethical dangers of some of the very technologies we see ubiquitously amongst us. Second, I'll talk just a bit about the idea familiar to any political scientist or public policy person that with all innovations often come unintended consequences. And I want to offer a couple suggestions about how we as researchers or how we as engineers or how, in my case, as a philosopher, we ought to think about attending to unintended consequences. And finally, I'll offer a quick reflection on something that Emma just described, conceiving of some of the technologies that we're developing as either competing with human intelligence or augmenting human intelligence, but the language I'll prefer to use is whether the technologies that we use and continue to innovate on aim to supplement human agency or to diminish the scope of human agency. So let me begin with the first of the 3 points, the various ways in which the social and ethical dangers of technology have become more apparent. You probably have your favorite grab bag or catalog of examples. I'll just offer a couple of them. So first, we can think about algorithmic bias, which is often a phrase used in news reports quite frequently. Algorithms aren't neutral. They encode some of the values of the humans, in this case engineers, who write the algorithms themselves. And so we get various instances where the algorithms, which to the end user might seem neutral or scientific, and in that case trustworthy, but produce various sorts of outcomes or results that appear to reflect a certain type of bias. You have your own examples of it. I'll just mention the buzz phrase. Second example, the one that's in the news very much this week, is how the efforts of engineers at some of the most significant platform companies like Google, Twitter, Facebook, produce an information ecosystem, or if you will, the search results or the news feeds that are one of the chief mechanisms through which almost all people receive and disseminate information. And so these platform companies have become something like the infrastructure for the very public sphere in which information is distributed and circulated amongst people. And it takes no computer scientist or engineer to reveal that these are not neutral algorithms in the sense that the companies that provide the news feeds or the search results are analogous to the tubes that conduct the water in the plumbing system, or as I once heard someone from Google describe about a decade ago, that Google is like the phone company. It just provides a conduit for the dissemination of information between two parties, the content provider and then the search results to the user, so that if you thought to yourself that Google was in certain respects culpable or complicit in bad results, whatever that might mean, it would be the equivalent of saying to the phone company when two people plot to commit a crime using the telephone, you don't think, let's sue the phone company for having made permissible or available that planning. No, you just hold the two people responsible. But of course, that's not what happens with the news feeds these days. These companies are engaged in curating, through machine learning and various other forms of computation, the very things that we see. The example I'd like to give is probably one that you're all familiar with. If you're on Facebook, you know that you probably have something like a couple hundred friends, maybe more. Whatever amount of time you spend on Facebook every day, you know that if you opt into the default news feed structure, what you get is not a list of everything chronologically. However the news feed's algorithm works, it's trying to provide selective exposure in whatever sequencing the news feeds come. So I'm unlikely to see, if I spend 15 minutes a day on Facebook, if, say, 25% of my friends actually post something every day on Facebook, I will almost certainly not see all 25% of my friends' postings. I'll see whatever Facebook's algorithm primes me to see or curates that I see, which is to say Facebook is involved, as other companies are, in curating the information that I get, even though it itself hasn't produced the content. So Facebook isn't in the game, and so that's what we see these days about fake news, echo chambers, the idea that what engineers are doing at Facebook is privileging, in a phrase I got from a colleague of mine, engineers privilege virality over veracity. And that's, of course, a design choice that the company makes and leads perhaps to some of the outcomes or worries we see today in Congress and elsewhere. Third example, already suggested by Emma as well, you might believe that with the advance of artificial intelligence, there's the prospect that the future of employment and work is threatened, that the robots will take our jobs. What type of responsibility does a company have for considering the very prospect of technological unemployment or technological displacement of people in the future labor force? Does it have a responsibility to try to avoid that? Does it have a responsibility if it thinks that it's going to be engaged in that process and thinks it's defensible to do so because perhaps there are more efficient ways of producing the outcomes that the human labor force would produce? Well, are there public policy solutions? You know, this favorite thing in Silicon Valley these days is tech companies endorsing a universal basic income as a way of imagining one way to provide a social safety net in a future in which employment is more difficult. Fourth, thinking about design choices that engineers make within companies whose products we use quite frequently. I have a teenager, and so I'm no fan of Snapchat, which I find to produce social disutility rather than utility. And when I think to myself, what are the ways in which engineers who get hired by Snapchat, what's the problem they're trying to solve? Well, in my distant understanding of it, what they're trying to solve is to nudge up the level or time of engagement on the Snapchat platform, which, as I say, if I find that to be disutility, for me, my family, my son, perhaps for the world, what good is Snapchat producing? Well, then I would find that problem that Snapchat engineers are solving, how to increase engagement on the platform, itself to be the wrong problem. And if you disagree about my own diagnosis here of Snapchat, think about the work of a guy named Tristan Harris, who has appeared in various newspapers about an effort that he has called Time Well Spent, that what most of these social media and app companies are attempting to do is essentially hack and commandeer our attention, and that what algorithmic efforts of engineers combined with really sophisticated behavioral psychology and economics, the ways in which the apps and technologies that we use on a daily basis are designed to stimulate the brain and reward our engagement on the platform, increasing slowly but surely the time that we engage with these apps and other things. And the question is whether or not the most scarce thing we now have available to us is our own attention. If any of you in the room are writers, I'm going to guess that some of my fellow panelists here, there's an app which I use religiously because I know I am susceptible to the predatory, algorithmic, attention-getting efforts of so many of the things I use on a daily basis. So the app I install on my computer is called Freedom, appropriately, which for whatever number of hours I set, shuts off all connectivity on my computer so that I can actually have 3 hours of focused time to write. Finally, I sometimes also think about the role that we have at the university with respect to teaching. And when I think to myself, apropos this last point about our attention and engagement on platforms, that at least so far as I can make out when I talk to the small sample of students whom I encounter, many of whom are majoring in computer science or engineering, they think it's amongst the very best thing that they could do to go work for a place like Snapchat so they can very marginally increase the amount of time spent on a platform. And so there's an effort that's begun here on campus to do something which I think you're familiar with too, which is to engage in civic technology or to find ways to take the extraordinarily talented undergraduate and graduate students who flow through the university and direct them not into ordinary Silicon Valley tech companies, but to companies which have a clear social purpose, a social enterprise, or even to lodge themselves within various forms of government agencies or nonprofits, doing the very same data science work that they'd be doing in a tech company, but now with an explicit civic purpose. So that leads to my second point, and here I'll be much briefer about these final two things. I said the second point I want to make is that virtually all policy has unintended consequences. And so one thing from a standpoint of a political scientist or a public policy scholar is that when you examine what the effects of any company's actions are, any engineer's actions, or any policy that's encoded at the level of the locality, the state, or the federal government, we ought not expect that all the things that the policy intended to bring about do come about, number one, and we ought also to expect that some things that we don't anticipate will happen. And what this suggests to me with respect to the ethical and social dimensions of technology, or ethical and social dimensions of the things that happen in engineering and in machine learning, artificial intelligence, is that there's no simple ethical checklist that anyone can just sort of get, as it were, like a little note card, a one-unit class in the School of Engineering taught by the philosophers at the university, so that you can sort of go through your little checklist of ethical issues, or you have a kind of professional code of conduct. You make sure that you've checked off your boxes, and then you're good to go. No, that's maybe a good thing to do, but since we know that the world is filled with unintended consequences, we always need to be, as it were, morally awake. And there's no point at which we can just shut off the moral and social dimensions of the choices that we make. I think about this in a trivial way about the simple and brute fact of human sociality, the fact that we are social beings, and that every form of human interaction is shot through with a moral minefield. And if we always think to ourselves, I am a fully ethical person, and everything that I do is consistent with the moral values that I express, that would be a form of moral arrogance that I think all of us would find distasteful. And what it suggests is that we always simply need to be morally sensitive to the complexity of human interaction. I think that engineers should have no reason to feel exempt from that basic and brute fact about human existence. Finally, the idea that what is being carried out by computer scientists, engineers, people at the forefront of machine learning and artificial intelligence is potentially coming at the cost of the exercise of human agency. So the efforts that many people often make and invoke is that what the technologies that are being championed ought to augment human intelligence, ought to augment human agency, rather than displace it or replace it. There still nevertheless remains questions about how it is that that will be carried out, whether there are design principles, as it were, in order to ensure that what we're doing is enhancing or augmenting human agency rather than diminishing it. I'll take a trivial example just to illustrate it. It's one that you might be familiar with. Let's imagine the case for autonomous vehicles that involves, from a public policy standpoint, something like the improvement of human welfare by a great magnitude because there will be so many fewer car crashes and injuries due to the algorithmic direction of automobiles. In the face of that empirical evidence, which I take to be one of the great promises of automated vehicles, there nevertheless can be imagined some people who feel like their pleasure in life comes partly through piloting an automobile, driving a motorcycle without a helmet on, because their agency is involved, they're making various decisions about it, and it's just a utility-generating activity for them. And that even if you were to demonstrate to them the incontrovertible evidence to show the improvement in aggregate human welfare that comes about by allowing yourself to be piloted by an automated vehicle, some people might nevertheless feel that it's a trade-off they don't wish to make. Why? Because their agency has been removed from the activity that they previously found value in. That might not yet constitute a good argument for the person still to pilot the vehicle. I just point it out as the kind of thing that we should be worried about from a policy standpoint as more and more technologies begin to replace the agential decision-making that we make as human beings, even if there are improvements in the outcomes we see at a collective level. Thank you.
Rob, that was great. Thank you so much. We have another word in my profession for people who ride motorcycles without helmets. We call them donors.
Donors, exactly.
Organ donors, that is. So it's my pleasure then. I think we'll just go down the... Oh, you want... Oh, you're going to go next. So my pleasure then to introduce Roman Chaudhry, the Senior Advisor in Artificial Intelligence, Senior Principal in Artificial Intelligence at Accenture. Please.
Thank you. I asked to go after Rob because I would just like to let you know that my PhD is in political science. So how does a political scientist get hired to do ethics in artificial intelligence? It's a very interesting story. Thank you for asking. I left my poli-sci PhD, I actually just finished this past year. I left a few years early after I finished my prospectus because there was this new exciting field called data science. And we didn't really know much about it, and frankly, a lot of people in my program made fun of me for leaving to enter this, Silicon Valley unknown field of niche people who do weird things. Now, if you know anything about academia, which most of you do, there is the sentiment that you only leave for industry if you can't hack it in academia. So then I come here, and this is why. Data science to me and artificial intelligence has always been about understanding people using data. That was why I became a political scientist. That's why I wanted to do my PhD. I wanted to understand human behavior, but understand it empirically. Now, when I came to Silicon Valley, I realized that there was a slightly different mindset because so many people here came from engineering. And to engineers, data isn't always about people. Data is about numbers, it's about code, it's about outputs, and it's about results. So before I joined Accenture, I was teaching data science at a boot camp. And for some of my students, I had to give them explanations and say, hey, you realize that when you have a false negative, if you're somebody, let's say, working at a major bank and deciding that someone's getting a loan or not getting a loan, that false negative means that somebody couldn't buy a home, maybe for their child to grow up in. Just think about that. And then this light would go off and they'd realize that it's a person being affected. And how can, it's not to say that you will never have negative externalities. It will happen. But to be more thoughtful in your processes and how you think about the projects you're building, it's not just about minimizing bias. It's about understanding how that bias is applied to people. So coming from an algorithmic perspective, the lazy language is to say we want no algorithmic bias. Anybody here who works with numbers and algorithms knows that's impossible. But really, it's to understand how our bias, whether or not there's something systematic about who it impacts and how it impacts. And by the way, most likely it's impacting those who are already discriminated against in society anyway. So now you have an idea of why I work in ethics and artificial intelligence. So Accenture approached me with this really interesting new idea, and this was about a year ago, to say that, everyone's really interested in artificial intelligence, but no one's really talking about the ethical implications. Would you like to do this? And I was surprised that they would take a chance on not only a political scientist, but somebody who hadn't worked at a major company. And I hadn't worked at a huge consulting firm. I have some background in consulting, but it wasn't this extensive Accenture-style leadership role. And they took a chance on me, and I'm thrilled to be in this position. I'll tell you why. I get to share a perspective that sometimes people have lost, and it's to understand that there's a human being at the end of all of this. So artificial intelligence, I like to talk about the 3 I's. It's immediate, it's impactful, and it's invisible. Immediate meaning that when you have some sort of an algorithm, when you launch some sort of an AI, there's some number of how many lines of code Amazon pushes out literally every hour. It's like hundreds of lines of code. They're constantly making little tweaks, whether it's to their recommendation engine, whether it's to some sort of visualization, whether it's to how they, who they target with their ads. They're making changes constantly. So it happens immediately, right? It's impactful because it impacts millions of people, hundreds of millions of people, right, around the world immediately. Finally, it's invisible, and that's the part I worry about the most. So whenever you hear about, a racist algorithm or a sexist algorithm, it's because somebody actually was able to look at metadata, look at the numbers up above. Myself, logging on LinkedIn, I would not know whether or not LinkedIn was showing me jobs that were of a lower salary than it would have shown me if I were a guy. Like Emma pointed out, we actually don't know the counterfactuals for an individual as they're impacted by these algorithms. So unless there is someone, something, some organization responsible for looking at this at a meta level, we actually cannot prove on an individual basis what would have happened had I not been a minority, had I not been a woman, had I not been from New York. We don't know. So that's what I worry about. And I want to point out something that Rob had mentioned about human agency. And I think maybe there's just this common language in political science. One of my subfields was political theory. So you'll like this story very much, actually, because it draws on political theory and philosophy. One thing I think about a lot is human agency and human responsibility. And it's not just human in the loop, but what is our role as, frankly, the people who are the most privileged in this space? We were sitting here at Stanford University, which is the hub, one of the major hubs of information, one of the major producers of this. We are so extremely privileged with the resources we have literally around, looking around in this room. We can tap the shoulder of the person next to us and learn something new and amazing. How do we understand our responsibility in this ecosystem? So I'll give you a story that doesn't seem related, but it is related. So at the end of World War II, we had just gotten out of actually 2 terrible wars. The world is pretty much devastated. Everybody asked the question, how did an entire nation, how did an entire people become complicit in the mass genocide of others? How did Germans and Austrians look at their Jewish neighbors who they would buy bread from and their kids would play together, and then Suddenly, this Nazi regime takes over, and everyone seems to be okay with the fact that these Jews are getting carted away. Everybody knew what was happening to them. There was no ambiguity as to what was going to happen. They weren't being relocated, right? They were sent off to mass murder. And that was a question a lot of philosophers were asking when the war was over. And we actually still ask that today in political science. Like, we investigate that part of history as this anomaly, as this understanding, right? So Hannah Arendt was this philosopher. She went to the Eichmann trials in Jerusalem. She wrote a book about this. There was a movie about her, I believe, last year or the year before. And what she came out with was incredibly interesting. She came out with this term called the banality of evil. What was so spectacular about Adolf Eichmann was his normalness. He wasn't particularly evil. He wasn't particularly smart. He wasn't particularly anything. He was just some guy. Right? And even in his trials, he would say, I always just wanted to fit in. And I joined the Nazi youth group because it's what everybody else was doing, right? So what he would say essentially was it wasn't my fault because I just did what I was told. And I worry that that's the direction tech is heading. Because when she coins the term banality of evil, she's saying that evil isn't just Adolf Hitler making speeches. Evil is also everyone who is so average and so boring and so nobody that they just shrug their shoulders and comply, right? I didn't kill Jews. I just signed the papers that bought the gas that gassed them in the chambers. I didn't actually kill anybody. This was the kind of narrative she was hearing. And that's very frightening because we all become complicit. So how does that tie in to artificial intelligence today? So I've coined this term. I call it moral outsourcing. So earlier I was referring to things like racist algorithms and sexist algorithms. And there's this book called Weapons of Math Destruction, which probably everyone in this room has either heard of or read. And now there's this public language that literally uses those phrases. And the problem with that phrase, right? So we anthropomorphize our data science, our artificial intelligence. We're already making it a human. Even though most of us in this room, all of us in this room, know that we are not in the world of artificial general intelligence, we're in the world of narrow AI, right? Our AI, as Dr. Fei-Fei Li so brilliantly put it, it plays excellent chess in a burning house, right? So it doesn't understand context, it's just really good at the thing it was taught to do. And yet we've already developed this narrative. And not only is it a narrative, it's a negative narrative. Racist algorithms, sexist AI. We say AI is taking jobs as if it has desires and it wants to take our jobs because it really wants to be a truck driver, this artificial intelligence, right? Really wants to be a truck driver. And the problem when we do that is we remove human agency. So both Rob and Emma were talking about human agency, right? So in that language of saying a racist algorithm, the human is now gone. So if I'm an engineer, if I'm a data scientist, and it was my job to make the algorithm that denied someone a loan because they were African American in Chicago, which by the way happened, I can say, I don't know, I was just doing my job, I'm a data scientist, I took the data that was given me, I put it in the model, I reduced my error, I did everything I was supposed to do, right? So banality of evil, moral outsourcing. The morality is not on me as a person who developed it and created it, it's on the algorithm. So here's the kicker, right? When the AI does something good, we say that I made this an AI that helps children, who can't walk be able to walk. Great. When it does a bad thing, we say it's a racist algorithm, right? So I bear none of the negative outcomes, but all of the positive. So the problem with that, taking it a step further, is not just that it is a moral imperative to make sure that we are responsible for what we build, but that laziness is what's driving this dystopian AI future narrative that's starting to take over. Because we've already started building this story where AI is bad and there are no people controlling the AI. We've already said that. So it is not too hard to think of the next step being Skynet, right? I get asked Skynet questions all the time. Every single time I give an ethical AI talk, I get asked about Skynet, right? And I started to, it would frustrate me incredibly because then we're not asking the questions we should be asking, which is, how do we build a code of conduct for data scientists? How do we build processes around good AI and good data science? No, instead, because in our heads, we've already developed a narrative of racist and sexist algorithms, and by the way, there are no humans to control it, now we've reached our dystopia. So I strongly encourage when we think about our data science projects or our AI projects to think about the human responsibility. So to that, I switch over to my work at Accenture. 2 parts to it, and actually both of them were brought up today. One is something I called responsible operations. Responsible operations is about literally creating a framework So we can say, sure, it's a data scientist's job, it's a project manager's job, it's the person's job, but it's my job at Accenture to make these things real and formal for companies to implement. So what is the framework of responsibility and ethics we need around the development and deployment of data science projects? So this is not just the data scientist. This is in its design, as Rob had mentioned, in keeping the human in the loop, as Emma had mentioned, but also making sure that you have a culture of responsibility. So if any of you have ever been under a timeline for a consulting project, you know that there are often times where you're reaching that end goal and you're just barely getting an MVP standing, right? And guess what the first thing is to go out the door, by the way, if you don't have a culture of ethics and responsibility. If someone raised their hand and said, hey guys, so I looked at the data and I realized that there are no minorities in this facial recognition data set, right? But if you have a week to turn that project around and you don't have a culture of ethics and a culture of responsibility and a way to address that question, guess what? People try to ignore it, right? Because it's a difficult thing to tackle. And because most people, especially people from hard sciences and engineering, aren't taught about ethical frameworks, ethical conduct in their work, it's very difficult to even start that narrative sometimes. If I'm a data scientist and I find this problem, who do I escalate this to? My project manager, the person I'm working for? So we're actually working on creating that ethical framework so you can have a culture of responsibility. Second thing we're thinking quite a bit about is the future of work. So our CTO, Paul Doherty, is coming out with a book. It's called The Missing Middle. And there is so much discussion about these jobs that are getting automated away. We're focusing on what are the jobs that are going to be created, how will existing jobs change, and what are the skills we need to actually achieve those jobs. So this is not just about factories getting automated. There was a great article in Bloomberg yesterday about what jobs on Wall Street are being replaced by machine learning and data science. And this is analysts, traders. I mean, in Silicon Valley, I think the #1 job that is in danger is the data analyst job. As we democratize data science, as we've seen today, as we automate these processes, as we try to decentralize, get rid of these bottlenecks, your average analyst will be struggling compared to a machine learning platform. So how do we enable these people to be better at what the future economy holds for them? So to wrap it all up, because I know we don't have that much time, I want you to all think about exactly how machine learning, data science, and all the stuff and all the power and privilege we have here can be democratized and used for regular people. And I'll end with an anecdote. This actually just happened to me yesterday. If you guys have seen The Big Sick or the show Silicon Valley, Kamal Nanjiani had this very, very long multiple Twitter thread yesterday where he talks about how as an actor, and when he films Silicon Valley, he has to come here and he goes to these tech conferences. And he's surprised and shocked because he sees all the cool stuff AI can do and machine learning can do. And when he asks in the room of who's thinking about ethics, no one has an answer. So in this room, we're all, as I mentioned, privileged, highly educated, senior management, right? But for the average data scientist out at Open Data Science Conference, which is going on yesterday and today, they're not thinking about this. And they're the ones that should be, by the way, because they're the ones on the nitty-gritty ground floor, cleaning the data, writing the base algorithms, doing that incremental 1% uptick on Instagram, right? None of them seem to know what the heck this guy, this actor, was asking him. And he was so deathly afraid. And that's exactly the narrative that's happening in America today. So, what's awesome, though, is the amazing things about all this connectivity. I actually messaged him, and he messaged me back. So now we're in this very interesting conversation on how we can get all the stuff we talk about in this room out to basically just the regular people, the people who watch Silicon Valley, not the people who just read MIT Tech Review and Wired, people who just turn on HBO. How do we get this message out to them? So I challenge you to all think about how we can democratize the information we hold in this room, and that's the only thing that will keep us away from this image of the AI dystopia that we're all fighting against today. Thank you.
Thank you so much. This is one of those moments when I really love my job. Just the opportunity to sit and listen is just remarkable. So our last speaker, just before we get on to the panel discussion, is Tom Khalil. He's Senior Advisor to Eric and Wendy Schmidt Group, also Entrepreneur in Residence at UC Berkeley, but we'll not talk about that. He is formerly the Deputy Director of the Office of Science and Technology Policy in the Obama White House, an office I believe has nobody in it anymore. Is that correct? Maybe. Anyway, Tom, please welcome.
Thank you. Good afternoon. Well, we're rapidly approaching the point in the conference where everything has been said, but not everyone has said it. So I thought what I would do is to talk a little bit about the role that philanthropy and foundations can play and perhaps should play in the fields of data science and artificial intelligence. And one of the important things to know about philanthropy is that when you've met one philanthropist, you've met one philanthropist, that there's an incredible diversity in terms of the topics that they're interested in. So let me just give you a couple of examples. So there are a group of philanthropists and foundations that are really interested in addressing some of the ethical and legal and societal implications of AI that you've heard about. So for example, there's a group that includes Omidyar and Reid Hoffman and the Knight Foundation that has been supporting some efforts like AI Now, which is beginning to explore some of these issues. So that has definitely gotten some attention. There are groups, there are foundations like the Moore Foundation and the Sloan Foundation that launched a major initiative in data science and the role that it could play in accelerating the pace of scientific discovery. And so they supported 3 universities, NYU, University of Washington, and UC Berkeley, to have those universities begin to explore what were the new models for preparing data scientists. So what are the new paradigms that are required for education, and how is a research university going to organize itself to deal with the opportunities that are created by data science? So that's a second group. But I think the third and potentially largest group might be foundations and philanthropists that are not interested in data science per se, but might be interested in the role that data science and artificial intelligence could play in addressing a societal challenge that they care about and that they believe is going to be that the private sector left to its own devices is going to underinvest in. And so let me give you a couple of examples of what it is that I have in mind. So one big opportunity we have around managing the global environmental commons is that by leveraging the supply chain of the consumer electronics and smartphone industry, Silicon Valley startups are creating satellites that are no longer the size of a school bus, they're the size of a shoebox. And that's going to give us a picture of the planet that is updated every 24 hours. And so the ability to use machine learning to take all that satellite data and to identify things like illegal deforestation or illegal fishing is going to be of interest to foundations and philanthropists that care about global environmental challenges. People are beginning to explore the role that data science could play in improving our ability to predict the energy production from intermittent sources of energy. So if we want to reduce greenhouse gases by 80%, we want to increase the role that solar and wind play. One of the challenges is that solar and wind don't work when the sun doesn't shine and the wind doesn't blow. And so a lot of utilities have been reluctant to embrace it because of their concern that they're not going to be able to maintain the reliability of the grid. So foundations that have an interest in accelerating the transition to a low-carbon economy are going to have an interest in promoting applications that could allow us to increase the use of wind and solar or to increase the energy efficiency of the built environment. In the area of K through 12 education, which is a topic that is of interest to a lot of foundations and philanthropists, one of the challenges that we have in education is that productivity is negative. And what I mean by that is we have doubled the real per pupil expenditures on K through 12 education, but there has been no corresponding significant improvement in student learning outcomes. So one question is there anything that data science can do about that? And one idea that I think is worth exploring is that data scientists and organizations that have large online and blended learning environments might be able to create an infrastructure for continuous improvement. So as opposed to doing an experiment in a classroom of 30, data scientists might be able to look at these online and blended learning environments that have lots of users. So for example, Duolingo, which is a language learning application, has 150 million users completing 6 billion language learning exercises per month. So both the ability to analyze that data, but also to do prospective A/B testing might allow us to create an infrastructure for continuous improvement, such that our understanding about how to help more students learn another language or how to help more students master early fractions would have advanced relative to where it is today. When Zorn Popovich, who's a computer scientist at University of Washington, who I believe worked on the refractions application, went around and talked to teachers about the best way to teach early fractions, he got a different answer from every teacher that he talked to. So as a computer scientist, one of the things he's interested in exploring is whether we can figure that empirically, if we can figure out what works and for whom and under what circumstances, by dramatically increasing the amount of data that learning scientists have access to. So I think there's a really important role that an institution like Stanford could play, given that it has a core group of faculty that are interested in data science and machine learning and artificial intelligence. And it also has lots of people on the campus that are interested in addressing these big societal challenges. And the ability to articulate for foundations, where are we now with respect to the application and use of data science and machine learning? Where would we like to be over the next 5 to 10 years? How do we go from data to knowledge to action? What are the decisions that the use of technology can help inform? And what concrete public and private actions would need to occur in order to move the ball forward? So for example, one of the things that a number of speakers noted is that in a lot of cases, researchers don't have access to the relevant training data. So that's something that foundations and philanthropists, if they saw an alignment between the machine learning and data science and their mission, that they might be prepared to support. I also think there's a big opportunity, obviously, to unleash students on these problems. And we heard from some of the early speakers that students are voting with their feet. They're interested in taking courses in this area. And so I think allowing students to major in a discipline but minor in a problem. So what would it mean from a pedagogical point of view if the goal was not only to crank out more computer scientists, but to increase the number of students that had a deep understanding of a particular problem and understood the broader socio-technical system in which that problem was embedded. So those, I think, are some of the opportunities for foundations and philanthropists and research universities to work together, not only to address some of the risks associated with artificial intelligence that the speakers have talked about, but to really maximize the societal benefits. One of the reasons I think this is important is that the ability of the federal government to support research and development varies widely across the federal government. So the Department of Defense has a research and development budget of over $70 billion. The National Institutes of Health has a research budget of about $35 billion. Does anyone know what the Department of Labor's research budget is? It's $4 million. So at a time when there are real risks of technological unemployment, of non-college educated workers seeing stagnant or declining real wages and declining levels of labor force participation, there is not a group at the Department of Labor that is thinking about these issues or fostering the development of an extramural research community that could harness some of these new technologies that could benefit broader swaths of American society. So I think there are some really important gaps in our national research portfolio, and I think that collaborations between research universities, civil society organizations, and foundations could potentially help address some of those gaps. So looking forward to the questions from the audience. Thank you very much.
Well, thanks so much, Tom, and thanks to all the speakers for really taking us through a potential future that involves no disease and no accidents and great happiness to one that is much more of a dystopian. I think Hollywood got there before us, but anyway, I would love, we just have 10 minutes unfortunately for the discussion, but I would love in that time to see if we can touch on both of those extremes, both the very fuzzy future and potential a little bit about how we might avoid the dystopia. Maybe let's start with that. First of all, one of the themes that ran through the discussion there was fake news, and some of you may have heard or been aware of the work that was featured recently on Radiolab, where not just were we seeing written fake news, but rather people were using an AI to basically put words into the mouths of our politicians, and there was a sort of fake Obama speech and a fake Trump speech, and that is a terrifying prospect, where essentially we can make our politicians appear to be saying anything in a video and then feed it to 1 billion people. I wonder, Emma, it's a while since you've been here, so maybe we could, do you mind if we start with you? And where do you think we're going? What can we do about that? And how can the work that you've been doing help us avoid that dystopia? Small question.
Yeah, small task. So I think the issue of fake news is a big one, and I think there's two separate issues there. There's the issue of whether we could create artificial agents that make it look like there's, politicians that are saying things that they actually aren't, versus just the general issue of how do you know what is verifiable and what is reasonable. And I think that's a really deep question. It's been something that's been studied for a while now. Now, instead of looking things up by encyclopedia, people look things up on the internet. And in particular, they don't necessarily have trusted sources. They just sort of do general Google searches. And I think that's a big challenge that we're going to see. That's not something that my own work personally looks at, but I think that there are a lot of tools and techniques. So just to give inspiration from this, I guess maybe almost 2 decades ago, people were looking at how could you verify whether an image was real. This is important for the really tragic cases of things like child abuse and pornography, so that you would know whether it was a fake image or a real image. And so I think that we'll be able to have similar techniques to understand whether it's a real video or a fake video, though there's certainly a lot of AI that's also trying to make that distinction smaller. But I think that the more broad issue of just how do you know what to trust is a really big one, and I think that's something that we're going to start to see education about in our systems, hopefully in our public education systems and certainly in our college, of how do you verify information when it is impossible to verify those things personally? And that in some ways is an age-old question. That's been true ever since we've had journalism. That's not a new problem, that we have to have trustworthy sources because you can't personally verify all of the news. But I think the fact that we have lost trust in a lot of people have lost trust in the media outlets, and that trust needs to be regained, and we need to sort of re-educate and re-understand what it means to trust news. In some ways, I think that's a much more of a policy and an education issue rather than an AI problem.
Yeah. So part of that the theme is, I think, and we heard this from everybody really, was that I think that AI researchers and the people practicing, whether in industry or in academia, have to take responsibility, and maybe there's a parallel group who are helping us work out if something is real, and maybe they're using some of the similar kind of technology. Maybe it's a standards-based thing. Roman, did you have a comment on that?
So there's a few things to think about when we, I don't think this one's on. There it is. I think there's a few things to think about when we think about fake news, right? So there are different kinds of fake news. There is literally the news that is generated that is incorrect, and I think Pizzagate's a really good example, if you remember Pizzagate from last year. Pizzagate is also an interesting example of something called disinformatia, right? Where you create nonsense news to flood the news feed, or, like, pardon my language, but as your kids would call it, shit posting. That's actually what that is, right? So you flood the internet with nonsense so that actual issues get ignored. that is also a form of fake news. And the third form of fake news that we're all actually very familiar with is just propaganda. It's not, you will see there were internet memes going out, making fun of one candidate or the other candidate at the last election that actually have nothing to do with dispersing facts or knowledge or anything. It was pure propaganda. So these three kinds of fake news, and they all feed into one problematic thing. So we can verify sources, let's say we know things are factual, but we know there is a very, very human fallacy of confirmation bias, right? So we believe at our core that certain things are right and certain things are wrong. And to draw on another poli-sci research study, which actually ended up being a bit of point of controversy in the poli-sci world, sort of unrelated to what we're talking about, we've actually found that people don't really change their minds on strong policy issues. And there was a lot of research done on people who are opposed to gay marriage. And you don't change people's minds. So what do we do about that? What do we do about that? No matter what evidence one may give, what proof, what facts, whatever, and we see it in the current political climate, people hold their ground and they get more staunchly rooted in what they believe to be true, especially or in spite of the facts that are given to them. So there's two things to worry about. And you brought up this idea of needing education. I absolutely agree. So when I was teaching at UCSD, was when I was doing my PhD. I was also teaching at Grossmont College, which is a community college, and I loved, while kids at MIT, where I went to undergrad, Stanford, and UCSD are all great, they're all trying to get that A, right? So they don't like to rock the boat. They don't like to ask difficult questions. But my community college kids, they were actually taking Intro to American Politics because they wanted to learn about Intro to American Politics. So I always got asked some really interesting questions. And one of my students said to me, I don't believe in climate change. And I told her, you could not believe that the sun won't, you cannot believe that the sun will come up tomorrow, but it still will, right? Then I realized that there is becoming this non-discernible, like we can't discern fact and fiction anymore, like fact and opinion. So her opinion was that climate change wasn't real. It's actually one of the most studied things that the EPA has studied, right? Climate change, et cetera, et cetera. It doesn't matter, right? It does not matter how much evidence there is. So there is this narrative needed around education, around facts. Like I remember as a child being brought to the library and taught about primary sources and secondary sources, right? And like dating myself when I say that, right? But there was no education given in the internet age of why you can't use Wikipedia you can't cite Wikipedia in your paper. I actually have to explain that to my students, right? What does it mean? Like why a blog isn't a verifiable source? Actually need to explain this to students. So there is this missing education. I totally agree.
Thanks. And I wanted we have a couple of minutes to go, but I really would like to end on a positive note. So so here's my attempt at that. And I'm going to ask Tom and Emma to speak to this. In this room, also, one of our well-known venture capitalists, Vinod Khosla, has told us in the medical school many times that doctors are out of a job, that I'm done, that an AI is going to be much better at detecting and curing cancer. I told him actually that if he wanted his cancer treated, he should go ask his computer if his computer could give him his chemotherapy. But he didn't answer that. But I wonder what really struck me though, and this is you spoke to maybe some of my bias, that the excitement around AI is in the way it can augment humans, and I really like that from what you said. And I wonder, Tom, also maybe first if you just had any thoughts on that interaction, the sort of human-machine interaction, that we can maximize our potential as humans by using these machines in the way that makes most sense.
Yeah, for example, I think there's some work on the diagnosis that shows that a pathologist and an AI working together is more accurate than one or the other. And I think the other thing is that in many cases, it's not that the job will go away, it's that the nature of the tasks that the human versus the machine do is going to change over time. I don't think there's anything shortage of things that need to be done in the world, and as long as that's the case, there'll be lots of roles for humans.
Yeah, that's great. And then Emma, we'll give you the last word.
Yeah, I think just to build on some of the comments that were made before, technology is not neutral. It can be used for positive or for negative, but we have a choice about that, and it's the humans that are deciding that. And so we can decide whether or not we want it to amplify the positive aspects or the negative aspects. And I think we've always faced scientific and technological change. This is not the first time. And I think that there will always be roles for humans to play. And I think if we make the right policy and policy decisions and choose
choices as a society, we'll see really big beneficial outcomes.
Perfect. Ending on a positive note, I like that. Thanks. I'm going to have Kevin come back up, and meanwhile, while he comes, I'll ask you to thank the panel.